Okay, this is Stephen Marcus. We're looking at homework 7, our homework. We've got 3 questions to jump into. We'll go ahead and just start with number 1. There's a file posted in Moodle called population.txt. You're going to download it, read it into R, modify it, order by population, and then write it out again in a file called population2.txt. The hardest part with this was finding where your file was. And what I did was I created a directory. This is a Mac, so it's users S Marcus homework 7. And right there is population.txt. So there's my path and there's my file. That's part of the battle right there. Okay. So let's start off. I'm just going to make a variable called B, and I want to read it as a data frame. And to read it in, I'm going to spell it right. Read. It's just a table. Tell you what, let's just double check. What are we looking at here before I go grabbing it? Let's do a cat of population.txt. This is not a comma separated file. This is a space delimited file. It's just populations of states is what it is. So we're just going to read that as a table. So that's why it makes sense to read table. Okay, so users S Marcus homework 7 population.txt. Let's see if that works just from the get-go here. I'm going to say run, and it works. Cute thing about RStudio is it gives us a way to look at our table using this. So yeah, it read it in. Boom, boom, boom. So at least that part worked. One problem that we have found is row number 1 contains the column names, which we really don't want that. So let's see if we can. I'm just going to cut and paste this. That's not what I wanted. I will now learn to cut and paste. Highlight that, and there we go. So I'm going to say, and R helps me, RStudio helps me. There is a header on it. And when you're reading stuff in, just sort of get in the habit, strings of factors equals false. You can read up on strings of factors, and you find out if you're going to change your data at all, just go ahead and set it to false. Okay, let's run that now. Okay, that should have gone from 51 observances to 50 observances. And let's see if it makes sense. Now state and population are my column names, and they're not part of the data anymore. So, yay. Okay, so what part of this are we interested in? We're interested in the second column. Bloop. There's the data. We also could say, just for giggles, since we're here, B, and see, RStudio gives it to me, population. Let me run it. Does the same thing. So we got 2 different ways to reference it, and that's fine. Let's do a table called C, and I'm going to take B, which is my data frame, and I'm going to give it the order function. I want you to order on B. And again, population, that's cool. And you can give it, it was specified in the lab that we wanted highest to lowest, which is decreasing order. So decreasing equals true. Okay, so let's run this bad boy and see what it gives us. I should get a C down here. Boop, 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 boop. B order. B, did I spell population wrong? I thought I put it in there. Population decreasing. Undefined columns selected. Okay, well, I know one problem that we're going to have. wasn't sure it was going to error here or not. The problem that we have, if you look at this, it's going to have a hard time sorting this because it's full of commas. So let's go ahead and just take those commas out. And I think it depends on maybe what version of R that you're running, because I did this before and it tried to it did it, but it started with the 9s and then the 8s, and it didn't pay any attention to the length of the number. So that's what kind of threw me there for a second. So we need to go through and on the second column is what we're dealing with as numeric. We want this to be a number. So, and we're going to use the G sub. In R, you use G sub quite a bit. This is a substitution. We're going to substitute the comma for nothing in B, comma 2. Now let's take a look there. We have lots of commas. Let's see if we can make this work. And we're just doing it on the fly. True enough. There. Now all the commas are gone. Now we stand a better chance at getting this command to work. Oh, it still didn't like that command. B. Oh. All right, let's take a good look at this. I've specified this and I've left out one thing. This all represents the rows. I need to specify the columns. There we go. And then run that. There we go. That makes sense. And now if we look at C, that looks more reasonable. Little commas can make a big difference. So the only thing left we need to do is to say write table, and we're going to write the data frame C, and I'm going to specify my file. Where do I want to put it? Users, S. Marcus, homework7. I think it said population2.txt. And I'm going to run that. Okay, let's hop over here and see what I have done. I'm just going to do head of population2.txt. I'm going to do an ls too so that you can see that population2.txt actually did make it. It did it, but there's some crud in there we need to get rid of. I don't want column names, and I don't want the row numbers on there, but that's easy enough to fix. Row names equals false. Column names equals false. So swing at this one more time and rewrite the file and go back. And now if I do a head, that's a Linux command. There we go. So now I just have states and their populations, and they're in descending order. Okay, so that's number one. Number two is a little hairier. It tells you to go and open the file, and the file that you're going to fetch is this one, fake data. It's an imperfect file full of fake student data. And if I say head of fake data, these represent what would be a student ID number, and then homework 1, homework 2, homework 3, and an exam grade. And there's some more junks in there too. There's intentionally some junk thrown into this file that you have to pull out. Additionally, it's not set into lab. I'm going to do a tail to get the last 10 lines of fake data. And let's look at this very last line. That is the number of points possible So that could be some handy information to have too. And if nothing else, we're going to have to pull it out of there because those aren't grades. That's just additional metadata that got thrown in. Let's read it. Download the file, the student's name, next next four are grades. Write a program, read the data into R, convert the data to a data frame containing those columns. We're going to figure out something called scaled score, and we're going to create a column called scaled score that's going to be the average, where 50% of the score is based on the homework columns and 50% of the score is based on the exam in the fourth column or fifth column, considering the names. It should come out as a percentage. And then we're going to use this scale and apply it to our data and then answer a couple of pretty easy questions. The big deal is going to be to get it in and to figure this scaled score. Okay. Let me get rid of some cruft here. Let's read this sucker in, and I'm going to, just to keep things clean, I'm going to do that. And we don't need C and we don't need B anymore. And I'll even clean this just for good measure. Okay, I'm going to start off and read in my data frame with DD. Now, did we look at this file? We did look at the file. This should be a CSV. This is a comma separated format. Boop, 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 so we can see comments. So we're going to do read.csv. And let's point it. Users, that's Marcus, homework 7, fake that data dot txt. If it's a text, yeah, that probably should have been CSV. But anyway, it's a text file. .txt, good enough. We saw there was a header. We know that trick already. So let's just say, yeah, we know there's a header, and we don't want that to go in as data. We want it to be our column names. Strings as factors, false. Okay, let's see what we read in. Boop. Run that, and now we have 97 observances of 6 variables. There we go. Let's take a look at some more of this cruft that's in here. That just needs to be pulled out altogether, as does 15. And I sort of know this file, so I know that's the only two rows that need to be pulled out. Plus, there's a lot of these. If there just wasn't data in there, R had no other choice but just to give it an NA. There's just no data there. So to make that work, I'm going to replace those with zeros. But we read our file in, so that's good news. And let's just prove to ourselves what it actually is. What is DD? And let's hope that it is a data frame. Good job. Let's take a look at, I want column row 97 and all the columns. What is that? That's that possible row. So let's assign that to something. I'm going to say, because we're going to need this for calculations later, possible equals DD 97. So this should create just one simple row, one observances. Just for giggles. It's a data frame with one row in it. Good enough. What's left over? I need everything except row 97. 97 observances. Okay. So I'm going to say LO, just to shorten leftover. So I'm going to say DD minus 97, which will pull out everything except row 97. So we should see a data frame pop in, LO, and it's going to be short one, so it should be 96 observances. And if I run it, there we go. And there's LO, and the last one should be gone, and it is. Okay. So we're beginning to work with our data that's left over. Let's tackle those NAs first. We see there they are. I'll close that. So I'm going to say LO. Wherever there is NA in LO, we're going to set that equal to 0. This is just say go throughout the entire data frame, and wherever there is an NA, set it to a 0. Let's run that and go through here. All those are zeros now. So if there's any in there, they will be actually something we can work with as a number. The other thing that we need to do is to pull out 7 and 15. Okay, so LO, and I'm going to have to make a vector to tell it, to give it a list of the things that I want pulled out. So I'm going to say pull out 7, pull out 15, but I still want all my columns. I remember the comma that time. So that should, this is LO that we're dealing with. Right now it has 96 observances. This should pull out 2, giving me 94 observances. There we go. And we can take a look. And if you look closely, 4, 5, 6, 8, 11, 12, 13, 14, 16. So it literally jerked them out of there. Okay, so the point being right now is now we have something, a bunch of data that we can work with. Okay, to save us some time, I went ahead and did the calculation on what we wanted to do. And this, we're going to build a column in leftover called scaled score. That's what the directions said we wanted. This looks funky, so let's just take it a step at a time. LO column 2, that's going to be homework 1. If we divide that by the possible of common 2, here's possible. Let's take a look at it here. So that's the possible, the score that's possible on that. To get a percentage and then to average those 3 together. So I'm getting an average of the 3 homeworks. And then once I've got that, that's going to be half of my grade. So that's where I multiply it by a 0.5. Go along with me there. I'm not positive that I like the way that calculation works, but that's the way that we're going to do it. The other one is actually pretty easy since it actually is on a 100-point scale. We just take half of it, and then we add them together to get a scaled score. We actually get a number, and it's going to be something that's reasonable between 0 and 1. So let's do this. Let's take a look at LO one last time. It doesn't have the scaled score in there yet, so let's run it. And it also says 6 variables. That should pop up to 7. Yeah, 7 variables. And it has gone through and it has added my scaled score. And it doesn't look like crazy numbers, so I'm going to say good. Okay, the next thing that we need to do, and again, I wanted to save us some time so this video wouldn't last forever because it took a while to type all this junk in. I'm creating a column called letter, and it's a big if-else, and you can slow it down and freeze the screen or whatever to take a look and see how I did this. They're nested if-else statements where we say, okay, if the scaled score is above 98, equal to or above 98, then this field is going to be an A+. If it's above 92, whichever one it fits, it's going to select. And I'm just going to kind of wave my hands and run it. And we should be up to 8 variables when that happens. There's 8. And if you look, these actually do make sense. This is actually more work than it is complicated. It's just a bunch of nested if-else's that it's going to select, and it's going to fall through until it finds the right one. The only thing that was a little funky about it was there's not a D plus D minus, and if anything falls below 60 you get an F, but there had to be a default. This last little field right here was if nothing else fits, and the command kind of had to have that. And at the end you just keep adding parentheses until it stops giving errors. There wasn't anything beautiful about that, but it worked. So there's what we've got. That's the beefiest part of it. If we go on to our lab, let's see what it wanted. It says, what is the average scaled score? Okay, average scaled score. How about if we say, what are we looking at? We're looking at the LO scale score. I kind of like using the names like this because it will just give it to you. And there you go. There's all my scaled scores. I'm just making sure that's the column that I want to deal with. This one is actually pretty easy. All you have to do is LO scaled score. So there you go. That's our scaled score, and that's a C. That's what it should be. It's about in the middle, so that's a reasonable thing. How many students received a B, 82 or higher? Okay, if let's say, take a look, and where LO scaled score is greater than 0.82. I don't want the first column. I want what column do I want? I want to see what the score is. So 1, 2, 3, 4, 5, 6, 7. I could have just used scaled score. Let's see what it gives us. That gave me everything. I mainly just want all the scores. There's all the scores. Are they indeed all over 82? And just giving a quick glance, yeah, they all are over 82. So it wants to know how many. The quickest way to do that is with length. And copy pasta. And there should be 50 of them. And that looks reasonable. Okay, so that's number 2. Number 3 is, this is the guts of it right here. It says make a function where you feed it 4 things. You're going to feed it a prefix, you're going to feed it a suffix, you're going to feed it a number, and then the number of digits. How many leading zeros do you want? The entire field. That'd be a field length. And if your number isn't big enough, pack out your field with zeros until it is this length. That's the gist of it. So, in the lab, it actually gives you a little bit of a heads up. There, give me some space. The command that we need is sprint F. And if you use sprint F, it's a formatting. It's a formatted print statement. 08D, comma. Okay. What this is going to give me, this is give me leading zeros up to 8 spaces, and then my number. So there's my example, 176. Yep. And if I say, how about instead of 8, give me 8, a field length width of 18. There we go. So that's the biggest hunk of this, is this sprint F statement. So we've basically got to build that on the fly. All right, make, what was it? Make string. Make string. And it is a function that is going to take a prefix, the number of digits, the number itself, and a suffix. Okay. So I'm going to try to build this off of what we have, and I'm going to call it num format. And we're going to use the substitute. Number is going to be in my example here. My size is going to be digits. Number D. Okay, number, the reference is right here. It's saying wherever number is. And I'm going to say print. There we go. We're pulling digits out of here. I'm figuring out it's going to be %0, then whatever I need in there. I want digits to go where number is, and then a D at the end that's kind of sneaky in there. Let's build a test case too. Make string pre. Let's make it 8 wide and 1, 2, 3 to keep it simple, and post. All right, we're going to start off simple and make sure that this runs. Okay, this print num format, that's what I needed. That is the format that sprintf is going to need in order to get my field width right. I'm going to create another variable called num result that actually uses the sprintf. Sprintf num format, and now I'm going to feed it the number to go into that format. And just in way of debugging, num result. And let's run all that again. Okay, so that's what it should be like. And again, just for giggles, I'm going to throw it, make it 18 wide, just to make sure it's working the way I want it to work. Yeah, that works. Okay, put that back the way it is. So there's my result. Result equals, we're going to use, let me use our syntax here. Paste. We're going to paste together the prefix, the num result, the suffix, and what we want to separate them. Sep equals nothing. And finally, return my result. Let's see if we can make it do it now. There we go. Pre, post. Now, to make the final thing a little bit prettier, I'm going to go back and I'm going to take out my debug stuff. And let's make it 18. Run it all together one last time. That's it. Okay, so that is homework 7.